Welcome to all of you. Today we discuss the topic Rutherford's experiment of scattering of alpha particles. Okay, we discuss the Rutherford experiment. Firstly, we know about the Rutherford. The Rutherford was a New Zealand born physicist and chemist who became known as the father of nuclear physics. From 1871 to 1937. Okay, he performed experiments on scattering of alpha particles from a gold foil having thickness 4 into 10 raised to minus 6 meter, and he obtained an important information regarding the structure of an atoms. Then we can see the alpha particles. Alpha particles is a doubly charged helium atom that has lost both of its electrons, or an alpha particle is the nucleus of a helium atom. Helium atom minuses its 2 electrons. It carries positive charge equal to twice E. And these alpha particles ejected from a radioactive material like radium, and this ejection speed very high of 10 raised to 5 meter per second, and it mostly carries high energy. Then it can travel through few centimeters in air before being stopped. Then it can penetrate through few hundreds or tenth of millimeters of a solid before coming to stop. It causes fluorescence on striking against certain materials. Then we can see the experiment of scattering of alpha particles. The scattering of alpha particles, this experiment performed by the Rutherford. He used radium as a source of alpha particles. It is placed on a small lead box. This radium source, which is placed on a small lead box, the box is provided with a small opening. A very fine beam of alpha particles is emitted along the axis of hole. The beam is allowed to strike a thin gold foil of about 10 raised to minus 6 meter thick. We see the diagram, this diagram, and this is first small lead box, then gold foil, microscope, fluorescent screen. Fluorescent screen. In this diagram, the box is provided with a small opening. In this opening, very fine beam of alpha particles is emitted along the axis of hole. This beam is allowed to strike a thin gold foil having thickness 10 raised to minus 6 meter. The gold foil scatters the beam of alpha particles in different directions. Then the alpha particles are received on the fluorescent screen coated with zinc sulfide or some other fluorescent material. When an alpha particles strike the screen, the flash of light is observed at the place when it strikes the screen, and the flash can be easily seen in the dark room by a microscope. Then it was observed that most of the alpha particles pass straight through the gold foil, but some alpha particles suffered small deflection and a very small number of particles were deflected through large angles. Only rarely a particle reversed back along its own path. In this experiment, Rutherford concluded that the entire positive charge and mass of the atom is concentrated in a small central core called as nucleus, and the diameter of the nucleus was found to be about 10 raised to minus 5 meter, and the nucleus is surrounded by a cloud of electrons whose total negative charge is equal to the total positive charge, so that the atom is electrically neutral. Okay, thank you.